Hello, this is section 4.2, writing equations in slope-intercept form. We're going to start with the easier version here, which is in the case where you're already given the slope. And so, for example, let's see, I think we'll move this for the time being and use this space. If you are given a slope of 3 and a point -2, 5, so m the slope equals 3, and there is a point -2, 5 on the line, and we want to write an equation for that line. What we're going to do is put the slope, first of all, we want it in slope-intercept form, so y equals mx plus b. We know that m, the slope, is 3, so it becomes y equals 3x plus b. Now, we don't know the y-intercept yet, but we do have a point on the line, and notice this point has an x value and a y value. Well, here's an x, here's a y, so we can substitute. So we put the 5 in for y, we get 5 equals 3 times the x value of -2 plus the y-intercept. To solve this, 3 times -2 is -6. 5 equals, we add 6 to both sides, plus 6, and we get b equals 11. Therefore, this equation is, let's put it over here, y equals, we have a slope of 3, 3x, we have a y-intercept of 11 plus 11, and there's the answer. All right. If you are not given the slope, but you are given 2 points instead, then you have to find the slope. Let's say you have 3, 1 and 2, 4. I'm going to leave the equation up here. We have 2 points on the line, 3, 1 and 2, 4. Now, the first thing you have to do is find the slope. To find the slope, you take the difference of the y values, 4 minus 1, over the difference of the x values, 2 minus 3. Notice, if I started here with the y values and did 4 minus 1, I have to start here with the x values and do 2 minus 3. I have to have the same starting point for both x and y. All right, that gives me 4 minus 1 is 3, 2 minus 3 is -1. That's a slope of -3. Now we need to plug that in here and find the y-intercept. So we have y equals -3x plus b. All right, we can now take either one of these 2 points, and I will show you how it doesn't matter. If I take the first one, 3, 1, remember this is x and this is y, 1 equals -3 times 3 plus b. This is -9 plus b. 1 equals, I add 9 to both sides, and I get b equals 10. So I have y equals -3x plus 10. All right, that's the solution, -3x plus 10. But let's try it the other way. Let's suppose instead that we took the second point, 2, 4. So let's do that over here. I have y equals -3x plus b, and I'm going to take 4 equals -3 times 2 plus b. So I'm putting in the other point. This is -6 plus b. 4 equals, I add 6 to both sides, and I get b equals 10. Exactly what we got over here, b equals 10. Therefore, I can put that back in, and I get y equals -3x plus 10. It did not matter which point you use, but you have to use all of this point or all of this point. In other words, you can't take the x value out of here and the y value out of here. You have to use the x and y from this point or the x and y from this point. All right, now let's see what else we might need here for this section. Let's see. The book here talks about constraints. Let me see if I can explain to you what I mean. For example, if you were if you were making a graph of a person's salary, and if the person worked 1 hour, he or she made, let's say, $10. Now I'm considering this to be 5, this to be 10, this to be 15, 20, etc., 25. Now, at 1 hour worked, $10 earned. At 2 hours worked, $20 earned. At 3 hours worked, $30 earned. All right? I can connect those points, but look, if I go all the way down through here and continue it on the other side of 0, 0, what does this mean then? That if I work -1 hour, I make -$10? No, that makes no sense. So we have to take this away and stop it there because it doesn't have any use down here. It's meaningless. Okay, I believe that tells you what you need to know for this, the problems I'm going to give you in this section. That's section 4.2 in your textbook. We will continue with linear equations. Next time we're going to be talking about point-slope form. Thank you very much.